electrode. Now, if these are the terminals or polarity, job is connected with positive pole, that is anode. Electrode is connected with cathode terminal. So where the maximum heat will be generated? On the work surface. If maximum heat is generated on the work surface, what will happen? Metal will be melted at a rapid rate, right? And as soon as metal will be melted, electrode will also be melted, getting the heat, and the droplets will be deposited here. So when this work is connected with positive polarity pole, electrode is connected with negative pole, this is known as direct current straight polarity, DCSP. Note it, D stands for direct current straight polarity, DCSP. DCSP means when job or work is connected with cathode terminal, anode terminal or positive polarity, and electrode is connected with cathode or negative polarity. So maximum heat will be generated on work. When it is needed? When thickness of the job is very high. Say if I take a very thick job, so lot of heat will be required to melt the piece. So if thickness of the job is very high, that is the geometric relation. And also for metals which have very high melting point, like ferrous metal. But what will happen, say if I take a aluminium foil, imagine a foil, thin, very thin. And that aluminium foil is connected with positive polarity. So what will happen? Maximum heat will be generated. Immediately, the foil will be melted or burnt. That is, instead of joining, burning will take place. So in that case, DCSP will not be helpful. So what to do in that case? In that case, the work should be connected with negative polarity, and the work electrode is connected with the positive terminal. So maximum heat will be generated here. This will be melted at a very high rate. No harm. Droplets will be deposited, but less heat will be generated here. So this will not be melted rapidly. This concept is known as direct current reverse polarity, DCRP. So when it is needed, when the thickness are very less, like foil, or when the melting point of the metal is very low. So DCRP and DCSP, these are two very important considerations. Okay? And this is only possible, mind that, if you use a DC power source. Because if it is a DC power source, this terminal is negative and this terminal is positive. So I can quickly change. If say work is to be connected with positive, just disconnect this terminal, connect with work, and disconnect this electrode terminal, connect with this negative. But in AC, you can't do that. Because in AC, alternatingly, this will positive, this will negative, this will positive, this will negative, and so on. So in that case, 50-50 heat will be generated. So I have mentioned polarity, this is the polarity concept. DC, direct current straight polarity, direct current reverse polarity are important when the geometrical shape of the job, that is thickness, is concerned, when the metal melting point of the metal, that is the material characteristics, when melting point is a concern. There is another concern, there is another concern, that is weld position. So what is weld position? So there are various weld positions like vertical, horizontal, floor, floor, also called flat, roof welding. And this vertical, say this is a surface, say this is a surface, wall. So I am welding, so this is the floor, say three-dimensional view. This is the room. Say this is the room. Okay. So I am welding on the wall vertically. So that is a vertical welding. Again, depending on where from I am starting, this is tops. I am starting here and coming down gradually. So this is known as downhill, downhill, downhill. Or if I start from this point and gradually move to upward direction, that is uphill. So downhill and uphill. This is the floor of my room. This is the floor of my room. And a crack has been initiated here. So to weld here, this is the floor welding or flat welding. What is horizontal welding? Say this is the wall, this is the wall. If I weld like this is vertical. Horizontal means parallel to the floor. So this is horizontal. Sometimes angular is also considered. Angular means some at an angle. Again, uphill, downhill. But roof, what is the roof? This is the roof. You just imagine, you just observe your roof where you are sitting right now. You look in upward direction, your roof is there. And a crack has been initiated at the inside roof area. So how to weld here? How to weld here? If you use, if you connect your roof with positive terminal, right? What will happen? Say metallic room. The roof is connected with positive polarity terminal. So maximum heat will be generated on that surface. And massive melting will take place, and the total metal will immediately come down due to gravitational pull of action, force of action. And nothing will be deposited very slowly. Metal will be deposited very slowly, very difficult, right? So, what is the suggestion? It is suggested if sometime roof welding is to be done, then tilt the object in upside down manner. Are you getting the point? Tilt the object in upside down manner. উল্টে দিতে হবে. So now it is like a horizontal or flat. So things will be deposited very nicely. But is it feasible or rather possible to tilt a room in upside down manner?
No, sir.
Is not possible. So why I am telling, in engineering application, like say there, say when you, if you visit some fabricating shop or rail wagon manufacturing shop, you will find when railway wagons, severe welding action is taking place. So when roof welding is particularly conducted, they are following this procedure, tilting upside down manner to have a solid weld, sound weld. But say, for example, very large pressure vessel, very large your ship, very large ship, where tilting in upside down fashion is practically not possible. So you must go for roof welding. And you know, if the metal is connected with positive terminal, massive melting will take place. Deposition of metal will be very, very slow. So remedy is to utilize the concept of polarity. In that case, roof is connected with negative terminal. Whether whatever may be the material, whatever may be the thickness, irrespective of that. So third point, when the polarity is important, that is the position, welding position. So there are three important factors to be considered to choose a or to select a polarity. What are those? Material property, geometry, that is thickness, and welding position. Is it clear?
Yes, sir.
So these are something about polarity. And now AC power source, if you use AC power source, uh, alternating current power source, we are tapping power from the bus line, from the main cable. So where the voltage is very, very high, that voltage can't be utilized. So I must take the advantage of transformer, step down transformer. Okay, so that will reduce the voltage, line voltage, to the usable voltage, usable limit. And when these transformers are used, that is quite in operation, noise is less, there is no noise, quite in operation, that is, and heat dissipation is also nil. So there is only small box, small. I don't know whether you are familiar with uh, AC transformer. Have you visited the laboratory after opening welding lab? No.
No, sir.
So AC transformer, that is a trolley type. Some wheels are also there, balls. So you can easily transport from one place to other place. So that is transportable, easily transportable. Noise is very less. That is quite in operation. No smoke or fume generation. So atmosphere will absolutely clean. No heat dissipation. So all these are advantageous point. But the only disadvantage is if you work sorry, in a project work quite frequently, say railway, laying the rail tracks, or in a say remote area, some new construction is going on where no power source is there. Now, how to utilize this AC transformer? There is no power source, so you can't use AC in that case in remote areas. So you must use another source, that is DC motor generator set, where no electricity is needed. But what is needed? Some fuel, oil based. As fuel is used, so smoke pollution, smoke generation will be associated. Sound is also very high for DC motor generator set. জেনারেটর চলে দেখেছো তো অনেক সময় জেনারেটর চালানো হয়,
Yes, sir.
it is associated with very sound noise. যখন লোডশেডিং হয়ে যায়, আগের দিনে ছিল বা অনেক সময় হয়। So noise, not only noise, as some lubricant, some oils is used, diesel or kerosene. So some smoke generation, fume generation, and also the surrounding atmosphere will be heated. Heat radiation is also likely. And not only that, the generator set is very heavy in nature. So to carry, transport from one place to another is very, very difficult. But only advantage is that in a very sophisticated factory, you may have all sort of facilities, power source, all these. Still, you may have to use motor generator set when the concept of or question of polarity is concerned. That is the only technical advantage or importance of using motor generator set. If it is particularly connected with roof welding, you can't help. You must go for DC motor generator set. Or for thin foil, large thickness of job, high melting point. So you can't avoid. So these are the advantages as well as limitations. Only 1 minute, I just am.
Okay, sir.
So these are the advantages and limitations of AC and DC motor generator set. Here, what are the advantage? DCSP, DCRP. So this is the major advantage or importance of using a DC set, along with so many others, all self-explanatory. So go through any book and find out the differences, distinguish between AC and DC welding or power sources. Now, how arc welding? So this is the scenario or arc welding mechanism. That is the electrode. So after some time we shall discuss about an electrode. So this is the electrode. Say this is the bare wire. This hatch portion is bare wire. Okay, and some coating is there. Coating material. The coating. Okay, covering. Why it needed? All these will be discussed. Now, as soon as so this is the job. This is the base metal or job, and this is connected with either positive or negative terminal or with AC transformer. Okay, this is also connected with either negative or positive or AC terminal, and they are being struck and separated immediately by a small air gap. So this is air gap. So arcing is taking place here. This is the arc column, this arc stream. How arc is established? So we had discussed electron theory,
Yes,
rectification theory. And due to this arcing, tremendous amount of heat will be generated, and there a digging by digging action. The metal will be melted and a crater will be created. Okay, and molten metal will be deposited. Molten this bare wire, that is a metallic rod. So that will also be melted and that will be deposited in this pool, in this crater. So this is the molten metal deposition, right? Molten metal deposition. Gradually, this thickness will be enlarged, and this pool of molten metal or the crater is covered by what is known as this gaseous envelope or shield. Why this gas is developed or evolved? Due to the fusion or burning of this coating material. So gas will be developed or evolved, and it will create a shield or protection envelope. And due to this gas shield, it is also very important. As this is a shield, মানে একটা ব্যারিয়ার তৈরি করেছে. So as this shield is created, heat will be dissipated from this crater or molten pool at a very slow rate. Slow heat dissipation. Now you
okay,
know,
sir.
I think you have you have gone through the forging shop.
Yes, sir.
Yes. So in this case, when the job is heated, sometime due to overheating, what you do?
ওই পাশে যে জলটা স্প্রিঙ্কেল করে।
Immediately deep inside the water tank.
হুম,
Yes. But what is the concept of this? From a very high temperature, dipping to a very low temperature suddenly is the concept of quenching, rapid cooling, quenching. Heat treatment, you know, heat treatment, you are familiar with this
yes,
term,
Yes, sir.
quenching. So, due to this quenching, particularly when the metal is enriched with carbon, martensite will be formed and immediately the metal will be cracked. Very brittle structure will be formed due to quenching, and immediately it will be cracked, crack formation. On the
Yes, sir.
contrary, so rapid cooling or rapid quenching is not desirable in various cases. On the contrary, slow cooling, that is normalizing. Just heat the job, place it below the normal atmosphere overnight or 2 days, 3 days, 4 days. Gradually, the heat will be dissipated. That will give very good mechanical property. So here, similarly, if the weld pool or weld metal get lot of time to be cooled, slow cooling, that is slow cooling, that will give sound property weld in the weld zone. So this gaseous envelope helps to reduce the heat dissipation of the weld metal. This is first point. Secondly, this coating material we shall mention, this is the bare wire, say made up of say copper or steel or the near material, base metal. What is the base metal? Say iron metal. So this is the iron rod. If it is copper element, copper metal, it will be prepared with copper. If it is aluminum alloy or aluminum, then this will be the aluminum, like similar metal. So when this is melted, and if this is covered with some coating material which is known as flask. Some metals will also be melted. Coating materials contain various precious material like cadmium, vanadium, aluminium, nickel, chromium. Okay, so that will also be melted and will be infused with the molten metal. So as a result, this alloying effect will be accomplished. The base metal will get some costlier element like vanadium, cadmium, chromium, so which are there in the. So this is the second advantage. Some good quality alloying elements may also be infused with the molten metal. As a result, uh, the ultimately the weld quality will be enhanced. Thirdly, there is another advantage. That is, as this is covered with a gaseous shield or envelope, right? And here we have atmospheric air, atmosphere. And this is the weld metal or molten metal. So what we had mentioned earlier, immediately after depositing a bead, we must use a chip breaker or chipping hammer to remove the oxide scale. So if the molten metal is unprotected, then immediately oxide layers will be formed. Oxide layer means in atmospheric air, so many contaminants are there: nitrogen, sulfur, oxygen is obviously there. So all the contaminants will make a scale, or which is known as DOX, dross formation, dross, SOx, NOx, that is dross, oxide layers. So as this shield is or barrier is created, so atmospheric contamination will be reduced. So there are three tiers advantage of using one flask material. Okay, 1 minute.
Okay, sir.
Here it is not written. Anyways, okay, I am just writing the. This is electrode, right? This is bare wire, is coated with some coating material. Is coating. These are the coating materials. So you just write, I am writing here in the chat box, what are the flask materials, just to, these are the FLUX, flux. Various materials may be used like ferromanganese, silica, silica flour,
Asbestos.
asbestos, asbestos, no, asbestos clay. So these are, so these are some flux materials that is used as a coating, and all these ingredients are bonded by sodium silicate liquid based binder. You know this thing. During our carbon dioxide welding, we had mentioned silica gel will be created, which acts like a cement like substance. Is not it?
Yes,
Can you
sir.
remember?
Yes, sir.
So all these are ingredients are bonded by this. Now, electrode classification. There are several standards to classify, but we follow American Welding Society. These are very common. American Welding Society or American Society for Testing Material. You should know this abbreviation, that is AWS, American Welding Society, okay, or American Society for Testing Material, ASTM. What is ASTM? If somebody asks you, American Society for Testing Material, and they classify electrode like this: E followed by 4 digits, or E followed by 5 digits. E means electrode. E stands for electrode. And in a 4 digit system, the first 2 digits multiplied by 1000 refers that much of minimum ultimate tensile strength. One example, say if I write E7016, what is the meaning? This is a 4 digit representation. E stands for, this is an electrode, and first 2 digits 70 multiplied by 1000, that is
1000.
20,000. That much of psi, pound per square inch. What is that? Is the ultimate
Tensile,
tensile
ultimate
strength that
strength.
will be expected, that is expected when the joint is prepared with this electrode. This third digit in a 4 digit number, this is the third digit. Third digit stands for the weld position. What is weld position? We have mentioned flat, horizontal, vertical, roof, all these. So one indicates this electrode can be used in all positions. 7016, one means this particular electrode can be used for all positions. But if it is 2, 2 means this electrode can only be used for flat and horizontal, not for vertical or roof. If it is 3, this is only applicable, or it can only be used for flat position. So obviously 1, which is 1, is more versatile. All this roof, etc., all this can be taken care of.
Yes, sir.
So this is the nomenclature. Similarly, in 5 digits also, in 5 digit, the first 3 digit stands for the ultimate tensile strength. This fourth is position, and then the last digit here, the last digit, that is the 4th digit, or here the 5 digit, stands for the current source or power source. What type of power source, whether it is DC or whether it is AC. If it is DC, whether it is connected with positive terminal or negative terminal, or what else. So that is about the detail of power source. And in this regard, you must follow a table, that is power supply and characteristics. Now, if say power source, say, in our case, we have
6.
selected one
6.
example where 6 was the power source. So what is meant by 6? You come
SCDC.
to this table. 6. 6 means power supply may be either AC or DC positive terminal. DC negative, no, AC or DC positive. And what is the arc action? That is the intense of heat. That is a medium heat. So medium. What type of flask? Low hydrogen flask. Low hydrogen flask. What is the nature of penetration? Medium penetration. Similarly, there are various up to 8 numbers. If it is 8, again AC or DC, here also AC or DC. So medium, low hydrogen, medium. So actually for AC, DC, these parameters are almost all same. But if it is AC or DC, say AC or DC, if it is 2, either AC or DC, no terminal positive or negative has been mentioned here. The digging arc action is medium. Type of flask, ductile material, ductile flask. Penetration is medium. Similarly, so many things, say if it is DC positive terminal, digging action, digging means more melting of the crater, flask, organic flask or mineral flask, penetration, deep penetration or medium penetration, etc. etc. So this is a table of power supply, regarding power supply. So at least you should remember at least one or two, if say in question a short note is to be written or some part is coming, then you should at least give some example where you should mention this. So you should remember at least one or two figures.
Okay, sir.
Another electrode, that is a corrosion resistant electrode. Corrosion is the unwanted wear of material when particularly due to chemical reaction. Not only chemical, there are 8 forms of corrosion. Unwanted wear. So to protect from corrosion, again, some electrodes are specified as per American Welding Society or American Society for Testing Material. So that is specified in this fashion: E 3 digits hyphen 2 digits. It means, say this is example E308 hyphen 16. The first 3 digit here indicates the type of steel. Type of steel means in steel handbooks there are so many type of steels, which is nothing but the chemical compositions. 308 is a very common. 308 means 18% chromium, 8% nickel steel. Chromium nickel steel. 18 chromium, 8 nickel. 18% chromium, 8% nickel steel. Chromium is corrosion resistant. Turbine blades are also enriched in chromium. And 1 stands for position. This 4th digit again is the position. We have mentioned is 1 means all
All
position.
position.
So here also position, all position. And 6 is the again power supply,
Yes, sir.
AC or
It's
DC power
DC
plus.
plus.
So
Yes.
in this way, these are the electrode specification. And another important concept is there in connection with welding on the say nameplate oil of the welding machine, AC transformer or DC motor generator set, there is a plate which indicates the name of the factory, name of something, date, etc., number, all these. Along with, there are 3 parameters that is mentioned. Those are mentioned. That is amperage, voltage, and duty cycle. This duty cycle is very, very important in welding because it is not possible to weld at a stretch for even 10 minutes. You may say, if you have a computer, or as we are doing right now, we are continuing for 1.5 hours. Another an hour will be continued with not that much of fatigue. But a welder can't weld continually for 2 hours. Never.
Yes, sir.
Right? His eye will be fatigued, his hands will be fatigued, all these. So here a concept of duty cycle has been introduced. What is that concept? This is a 10 minutes period. Duty cycle, it is a standard. It is a 10 minutes period. So when a welder welds for continually for 10 minutes, then after that his welded part will be observed and inspected, and say if 60% is the duty cycle, it means when the operator operates for 6 minutes out of a 10-minute cycle, 60%, 6 minutes out of 10-minute cycle, with the rated output means the rating factors are written on the nameplate of that machine. Say 300 ampere 40 volt is the rating cycle of that particular machine. So if the operator operates with those rating factors, that is 300 ampere at 40 volts at a stretch for 6 minutes out of 10-minute cycle, he can work for 7 minutes also, he can work for 8 minutes also, he can work for 10 minutes also, but without overheating or without making any damage. So that is the question. You may weld for continuously for 10 minutes, but your weld quality is very bad, so that will not be considered. If you can weld for 4 minutes, but that weld is a perfect weld without overheating, without damaging, without making any sort of problem. So that is considered as the duty cycle. Duty cycle may be 10% also, no problem. So that depends on the skill, ability of the welder. Okay, so this is the important consideration of duty cycle. Another factor is very important when the welding is arc welding is considered. Three factors are very important: speed of the electrode travel, speed of travel of the electrode, ek number. Second is voltage, so speed of the travel of the electrode, then voltage. This is 14 approximately 24 volt for bare wire or lightly coated wire, lightly coated electrode, bare wire for bare wire or lightly coated, lightly covered electrode. But this is 20 to 40 volt for semi coated and coated electrode. More voltage is required for coated electrode. And another parameter is amperage, that is current. Usually this is 500 ampere for manual operation. And this is why, because this maximum 40 volt are used and only 500 ampere is used, so we are not feeling any shock. Low volt operation.
Right, sir.
আচ্ছা, এখন কটা বাজে? Do you want to have some break or should we stop? What do you suggest?
কিছুক্ষণ একটু ব্রেক দিয়ে স্টার্ট করুন।
হ্যালো,
হ্যাঁ স্যার, ওই 2 মিনিটের মতো একটুখানি ব্রেক
হ্যাঁ
দিয়ে
স্যার,
আবার
একটু
স্টার্ট
ব্রেক দিন স্যার। Yes, sir.
ব্রেক করে আরেকটু এগোনো যায় নাকি?
Yes, sir.
তাহলে 5 মিনিটস?
Okay.
Okay, okay,
So, so right now this is 6:35. So we shall return at about 6:40. Is that okay?
okay, sir.
Yes, sir.
Okay, sir.
Okay, sir.
Okay.
Hello.
Yes, sir.
Hello.
Yes,
Can we
sir.
start?
Yes, sir. Yes, sir. Definitely.
Hello.
Yes, sir. Hello. We can start,
Okay.
sir.
Okay. Now, so as we had mentioned, so we had discussed about arc welding, heat source. What are the heat source in arc welding? Either AC or DC heat source, and the advantages and limitations of AC and DC sources, the polarity concept, DCPS, DC RP, DCSP, various welding positions, then the how arc is established in between electrodes, that is electron theory, arc column theory, electron and electrical theory. Electron theory is more powerful. Then we had mentioned about electrode classification as per American Welding Society or ASTM, classification of corrosion resistant electrode, the function of the coating material, three-tier function, three advantages. So these are something we had discussed in connection with arc welding. And as we had mentioned, there are various other welding techniques. So many techniques are there. Some of them are uh, older techniques, some of them are newer techniques, and so on. So carbon arc welding is one of them. This is not that new, but it is another technique. Arc welding, as the name suggests, this is also an arc welding, carbon arc, where nothing but you just observe the figure here. This is the old metal or base metal. This is the molten pool, and here a carbon electrode electrode, as per now we had mentioned about electrode, either bare wire or coated electrode. So bare wire means basically the material, either aluminum or copper or ferrous metal, that bare metal. If it is if it is not coated with any coating material, so bare wire. But if no metal is used, but carbon rod is carbon rod, carbon electrode. So as carbon, obviously it is very conducting material. So it will be connected with one of the terminals, either positive or negative. Work will also be connected with either positive or negative. As soon as arcing will be started, this is the arc flame, and heat will be generated. Metal will be melted, and a molten pool of metal, gradually it will be solidified. But there is no gaseous envelope, mind that, as this is not coated with any coating material. And also, this carbon is not melting. Like in a electrode, there is a bare wire being covered with coating material. So bare wire, bare metal is melted. But here, no metal, that is carbon, is not melting. So that's why additional filler rod is used here. This is not connected with the terminal, but getting the heat from this arc, this filler rod will be melted. So metal will be deposited here. But here, the problem is uh, some parameters are mentioned here. Later on, you may go through any book, or I may give you these slides for some guideline. So many books are there, you just go through, but just I am discussing the principle of this. But what is the problem? When carbon rod is used as an electrode, so carbon will be infused in this molten pool of metal. And as carbon is infused in this pool of metal, that is in the weld pool, this will become porous and brittle, right? So if carbon is infused here, the metal will become porous, that is weld pool will become porous, and it will be brittle also. But this is the technique, that is carbon arc welding. This is already mentioned, the differentiation. Now another two, these are also those though this TIG MIG you are also familiar with. TIG MIG, TIG MIG, though these are also like carbon arc welding, these are also not that new, uh, but still they are considered as advanced welding technologies. Advanced welding technologies. So what are the other advanced welding technologies like laser welding, atomic hydrogen welding, electron beam welding, friction star welding, right? Similarly, MIG and TIG welding. So what is TIG and MIG? First here, TIG, T-I-G, TIG, tungsten, this tungsten inert gas welding, T inert gas welding, TIG, also known as gas tungsten arc welding. This is another name, the same thing, gas tungsten arc welding, GTAW, TIG or GTAW, same. And here, this is the setup. This is the piece, and weld bead is deposited here. A job is connected with some terminal here, and this is the electrode. Now, what is the electrode here? This is the tungsten electrode, where this tungsten electrode, you observe here. Tungsten electrode is non-consumable electrode. Now, in carbon electrode here, it will be consumed, it will be infused, carbon will be infused gradually. So after some time, this will be used up. Similarly, electrode, when we are using electrode, rapidly the electrodes are consumed, consumable electrode, right? But tungsten, this will only help in arcing. It will not be consumed readily. But that doesn't mean it is that concept is non-consumable electrode, but it doesn't mean never it will be consumed. Say if you use for 1 year, 2 year, after prolonged use, obviously the length will be reduced. But that is not the concept of consumption, right? So here a fixed tungsten is a costly element. So tungsten, and all these are mechanism, and these are the electrode holder altogether, that is inside. What is the name of this method? Tungsten inert gas. So there is a cable, say this is the cable, hollow pipe, through which shielding gas, inert gas, nitrogen or carbon dioxide or helium, argon, okay, no, that is inert gas, carbon dioxide, helium, nitrogen, argon, some gaseous envelope, gas is passed here in the work area. So gaseous envelope, inert gas shield is formed here. And if required, we may also utilize one filler material, filler rod. And here, shielding gas is entering here, it is covered. Sometimes it is also covered with some water jacket, because heat will be generated to dissipate the heat, to reduce the heat. Sometimes water recirculating water is provided. So here this is the tungsten electrode, which is covered in a gaseous envelope, and this is a inert gas, tungsten inert gas, or also known as gas tungsten arc welding. Inert gas is used, inert atmosphere. Aluminium industries, aviation industries, they utilize this TIG welding. Aluminium welding is uh, in aluminium industries, the TIG welding is very prominent. So this is the description. You any book you will get this description, and this inert gas, shielding gas, like shielding gas like argon, inert argon or helium or carbon dioxide. Okay, both DC or AC can be used. So these are some technical points, pressure regulator, etc. So you just go through any book systematically, jot down some points, and also draw the figures, good figures. Try to practice good figures. And another TIG, tungsten inert gas. Another concept is MIG, metal inert gas. MIG, MIG, not TIG, MIG, metal inert gas, any metal other than tungsten. And here, this is a consumable metal, consumable. Now, what is the difference between a ordinary electrode? Here it is covered in, or it is working in gas shield envelope. So that's why inert gas, metal inert gas, but in ordinary electrode there is no inert gas. That is working under atmospheric air. And here it is also written as GMAW, just like say GATW, GTAW, gas tungsten arc welding. This is also known as gas metal arc welding, or MIG, same thing. And here a bare wire. So there is a reel feeder. In our welding workshop also we have a uh, MIG setup. Now this is a reel, and through this reel, this is rotating. So there is a bare wire, bare rod. So two rollers are there. So there are two rollers. So if this roller say rotates in this direction, and this roller rotates in this direction, and the wire is passing through these two rolls, so what will happen? This will be advanced in this direction. So there is a reel or wire reel. So gradually this is consumed. Here this is the total setup, that is a gaseous envelope. So inert gas is fed here. So inert gas envelope, again helium, carbon dioxide, argon, those may be used. And we may also recirculating water to reduce the heat. Okay, so this will be covered. And in the workshop, if you observe this gas MIG, the spatters will come out. Yeah, sound will be there. You can also observe what is going on inside, because there is a clear gas shield, gaseous envelope. From this envelope, atmospheric contamination is prohibited, but you can observe what is happening inside. So this is a power source, and the electrode is a bare wire, bare or uncoated, and also consumable, not non-consumable tungsten. So here no filler metal is needed, because electrode itself acts as a filler metal. But in TIG, we supply one filler metal. So these are the some technical points. Okay, mixture of argon, carbon dioxide, or only argon, only carbon dioxide. All these are the research work. Mixture of 75, 25, 80, 20, which will give the good result. And you should know the electrode, what is used not only here, everywhere. The bare wire, that is the electrode, it should be such a material which is almost same or nearly the same. Same means chemical compositions are almost the same that of the base metal. Otherwise, mismatch will be there. Now, another interesting. We have mentioned about arc welding. Arc welding. We have also mentioned about metal inert gas welding, where inert gas envelope is created to protect the weld pool. But the spatters are coming, sound is coming, heat radiation may be there. So to protect all these and also to provide the envelope, shielding medium, another concept emerged that is known as submerged arc welding or SAW. Now, what is submerged? That is, this arc, this is say a base metal here, workpiece, and there is a wire reel, or that again a bare electrode, just like MIG, a wire reel is there, a bare electrode. These are the rollers rotating. As these are rotating in this direction, so it will just pull the wire here. And this is also a consumable metal, right? And here we are not providing any gaseous envelope. On the contrary, here you just observe a flux tube, where from some flux material, a flux hopper is there, flux material. Now, what is flux, that we shall discuss. Some flux material, some solid, either powdery or some granular, powder or some granular mass. So this flux material is provided, and they completely, say, you just imagine, say if mm, some if you cover some portion with some handful of sand, right, you can't see what is happening inside. It is covered with sand. Just like that, some flux or granular material is provided here. So the total weld area where the arcing is taking place is not visible from outside. But in MIG welding or TIG welding, you can observe what is going on, what is happening, because this is a clear gaseous envelope. But instead of gaseous envelope, here some flux material is provided by hopper. And as the welding is completely continuing under this blanket, so this is known as submerged under a blanket of granular flask. And this is also protected from the atmospheric contamination, not by gaseous shield, but by the blanket of granular flask. We also have in our workshop a submerged arc welding setup in Blue Earth machine shop. Now here, these are the description, some description, but important is, what are the flux actually? What is this material? Flux may be of two types. One is fused, another is infused or unfused. and we may have is unfused. One is fused flux, one is unfused flux, or say known as bonded flux and agglomerated flux. So we are not going through detail. You go through any book, so things are there not in detail. You just learn at least partially. But this is unfused. These are the detail. But say this is the list of what are the materials: submerged arc welding flux type. MS is a code. What is that material? Manganese silicate. Manganese and silicate. And what are the major ingredients? Manganese oxide, silicon oxide, SiO2, SiO suffix 2, and it is greater than 50%. And what are the features? Silicon and manganese transfer is possible together with wires of low manganese content. So these are some description, but there are many more like calcium silicate. What are the ingredients? Major ingredients: calcium oxide, magnesium oxide, silicon oxide, greater than 60%. Similarly, AR means aluminate rutile, where ingredients are Al2O3, aluminum oxide plus titanium oxide, TiO2. FB fluoride based, calcium oxide, magnesium oxide, manganese oxide, calcium fluoride. Or we may have silicon oxide, calcium fluoride. So not a single material, but so many ingredients may be bonded together. So this is the flux. Or this is again a research area where several researchers are developing various fluxes using different materials in different quantities, proportions, and experimenting. Okay, so this is the submerged arc welding. Atomic hydrogen welding is another advanced welding technique where the heats, all these are nothing but to provide the heat source. Atomic hydrogen welding. It is a thermochemical, both thermal as well as chemical reaction is taking place, both thermal and chemical, thermochemical. Now, how heat is obtained here? Heat is obtained by passing a stream of hydrogen through an electric arc struck between two tungsten electrodes. So here you just observe there are two electrodes. Tungsten electrode, again one electrode, tungsten electrode. So as soon as they are struck, this is the workpiece. This is not connected with any polarity. But the terminal, this is the AC transformer set where 3 volt, 300 volt is the rating. So two terminals are connected with two tungsten electrode, mind that, not with work. And here hydrogen is passed. This is a inert envelope. Sorry, not inert envelope. This hydrogen, this is atomic hydrogen. So as soon as these two electrodes are struck, so one arc will be formed here. The shape of the arc is fan shape, this fan shape. And as soon as hydrogen is fed from another cylinder, hydrogen is fed here. Okay, so that will be converted into atomic hydrogen, getting the very high heat. So that is the concept. Heat obtained on passing a stream of hydrogen. Here a stream of hydrogen is passed through an electric arc. This is the electric arc. So hydrogen is passed and the heat is atomic hydrogen is produced and enormous heat is produced. Filler rod may also be used or may not be used depending on the requirement. There are various technical details, complexities, but you don't go for that. You just draw a schematic diagram with proper level and just discuss the phenomenon. Two electrodes are striking, that is the principle, and hydrogen is fed in this fan-shaped arc. So atomic hydrogen is produced and tremendous amount of heat is generated. And the shielding gas is also, this is also hydrogen shielding, as the hydrogen is fed here. Okay, atomic hydrogen. So these are the description. Gas welding we have already mentioned. What we told to start with, these are the gas welding. Oxygen cylinder pressure 125 kg per square, high pressure, all these are high pressure, or 2200 psi. Acetylene cylinder 16 kg per square centimeter. But you must, what I told yesterday also, you must use some regulators, gas regulators or pressure valves, all these, because our line pressure or working pressure for oxygen is about 1 kg, for acetylene about very low 0.15 kg. But cylinder pressures are very high, so you can't utilize directly. So there must be regulator valves, pressure, two-stage pressure regulator valves, and all these. Check valve, all these very important. Check valve, because otherwise explosion may take place. Because our working pressure should be for oxygen 1 kg, for acetylene 0.15. These are the setup. All these valves, regulators, all these are there. Knobs, and this is the cables. This is the torch. These are the flames. Again, in any book, these are not very good picture, but in any book you will find there are various inner cone and three heat zones. Inner cone here in between some 1260 degree. Here this is 2300 degree Fahrenheit, and so on. Oxidizing flame, some nature is something. Carbonizing flame, there are three distinct zone, and neutral flame. But here neutral flame, oxidizing flame look same, but here for oxidizing, the inner cone is very sharp, pointed, but here it is not that pointed. And here this is also bluish in color with a hissing sound for oxidizing. Again, these are the some write-up. Now these are the reactions what we mentioned yesterday, or acetylene
Yes.
C2H2 plus oxygen. But this is say complete combustion. What is here? All these are written. That is second stage, first stage combustion. Don't worry. Neutral flame, oxidizing flame, reducing flame. And these are the comparative say pictures of the various flames. Neutral means when oxygen and acetylene 1:1. Oxidized means oxygen portion is dominating over acetylene. And reducing or carbonizing means acetylene portion is dominating over oxygen. Obviously, it will be incomplete combustion. So outer envelope will be some yellowish. All these are neutral, and temperature is important. This is a oxidizing of 1.5:1, maybe oxidizing. Reducing, maybe reverse. Now gas cutting, what we had mentioned, gas cutting, ferrous metal is suitable because iron oxide is produced first. This is the reaction Fe3O4 plus this much of heat. And this is approximately 1 cubic feet of oxygen is required to oxidize about 3/4 cubic inch of iron. Now, this is important. Another two important aspect is bridging and soldering. You are also familiar with these two terms, that is soldering and bridging. Particularly in electrical wiring, electricians, they use this shoulder torch, right? So that is a low heat technique, low heat joining. And this is a method again, not this is not the concept of welding, uh, because both the parts are not heated, not bring to the fusion point like that. But how the joint is made, the joint is made by means of a fusible alloy. Fusible alloy is known as shoulder. For that, we must have a shoulder iron. So before starting the operation, the solder iron is heated. The electrician, when they are coming, they are plugging the solder iron for some time. When heat is sufficient, and heat is not that high, only melting range of the solder material is only 130 to 350 degrees centigrade, depending on the material. So after initial heating, that solder is melted by using that solder iron. You just remember, I don't know whether you are familiar with, there is a can, small can or tin, where solder iron is the paste is there. And this is the solder rod, soldering iron, right? Okay. It is connected with a cable and a plug, all these. So when this is plugged in and this is heated, this tip is heated to about 130 to 350, and this is now dipped into this paste, which is called a solder. And again, depending on the components, there are soft and hard solder. What is soft solder? Soft solder is only used for joining wire. This electricians, they use this soft solder wire or very small parts. Plumber are also using, plumbers. So where soft solder means this material, soft solder material is a mixture or an alloy, a composition of lead and tin mainly. This lead and tin. Okay. And what is this? Sorry, well, I'm sorry. In this can, there is a, not the shoulder. This is a can containing the flux. Okay, flux. And shoulder wire looks like a small wire. Okay, small wire. And this is the shoulder iron. Now it is heated first, dipped into the flux, and then it is also placed under this heated tip, so that will be melted. This tip will be melted, and say this is to be joined. So this shoulder tip is placed here, heated shoulder tip mixed with this flux, and then this will be melted and will be deposited here. So here, in case of soft solder, where soft solder means the material, that is alloy material, fusible alloy material, they contain only lead and tin. Number one is soft solder, where 37% is the lead, 63% is the tin. If it is medium solder, 50% lead, 50% tin. Plumber solder, 70% lead, 30% tin. Plumber, the water connection, etc. are made. 70% lead, 30% tin. But electrician, they use 58% lead, 42% tin. Another term is bridging, that is also a joining. It is also similar to soldering, but it will give stronger joint than the solder joint. the joint will be much stronger. And here a filler metal is used. Here also a filler metal is used, a flux metal, not filler metal. Here is a flux metal is used here in shoulder, which is basically zinc chloride. Zinc chloride. The tin, the can or tin contains a flux material which is nothing but zinc chloride. But zinc chloride is a corrosive. Corrosive. Still, it is used. And when the alloy is made with tin and lead, this is called soft shoulder. And when this alloy is prepared with silver with tin, not lead, if this is replaced by silver, Ag, and tin, then it is used as hard solder. What is the difference? The melting range is now from 60 to 900 degrees centigrade instead of 130 to 350. So these are soldering. And brazing is also same, but here this is something is used for mass production. And here a filler material, hard filler material is used, which is known as a spelter. This is a technical name, commercial name, spelter. And these spelter filler metals may be either copper based alloys or silver based alloy. For hard, very hard, silver based alloys. For softer, copper based alloys. Accordingly, their melting temperature is very high, 850 to 950. So just like soldering. Spelter is a technical name. Spelter is particularly connected with brazing. This is a filler metal. So soldering and brazing. So these are discussed. We had discussed. So these are some figure of this spot welding. So a weld electrode, and here this circuit is there. This circuit, this part obviously will be there. Okay, this left hand side will be there, and this is electrode. This is electrode. From this point, this is. But this part obviously you must draw during your examination. You must draw this part also. That is the other part. Okay, so
Yes, yes.
primary coil and power line, all these.
আগের দিনের ক্লাসে এটা
হ্যাঁ হ্যাঁ হ্যাঁ, ওইটা আঁকতে হবে, ওটা কমপ্লিট ফিগার হবে, যে কোনো বইতে দেখবে বুঝতে পারবে। দিস ইজ সিম ওয়েল্ডিং, just roller electrode is used, so it is rotating, so position is changed, and continuous welding spots, continuous spots are developed looking like a seam. This is projection, just this upper part is dimpled or a corrugated shape is provided, so that simultaneously all the spots are getting heated, and at it in a single pressure the welding is made. Flash butt and offset butt. In flash butt there is a gap and arcing, and now you understand how the arc is established, arc column theory. So this is the nature. After the joining, a protruded portion, a nugget shape is obtained. And here this is flash butt, but offset butt means both the ends are connected. There is no gap.
Yes, yes.
Now laser beam I am not discussing today, if possible, because today there are some other laser beam welding and electron beam welding. So something like this. So next class we shall. So this is laser welding and thermite welding. Okay. So in the next class, electron beam, thermite welding, those will be discussed. Is it okay, or should we discuss today?
স্যার আচ্ছা তোরাই থাক স্যার।
আচ্ছা আজকে এতটা অনেকটাই হয়ে গেছে, একটু দেখবে বই। So next class means next Friday.
Yes,
So we
sir.
shall discuss the rest portion along with some other. So we are almost in the verge of completion, because after discussing laser beam, electron beam, And what is that? This
থার্মিট
কি বললাম?
থার্মিট বলেছে।
Thermit, yeah, thermit is chemical. So after discussing those things, then we shall switch over to our almost the last portion, that is the additive generative manufacturing or additive manufacturing. That too in a nutshell, because just that is the introductory additive manufacturing, right? So that with
Okay,
that we
sir.
shall conclude. Any question?
নো স্যার।
Okay then. So you send me CR, you send me the attendance also. Okay then. Okay. Good night.
Okay, sir. Okay.
ওকে স্যার,
Thank you,
গুড
sir.
নাইট স্যার। থ্যাংক ইউ স্যার।
Good night.
Good night, sir.